Hi everyone, Will from Runchat here. In this tutorial we are going to learn how to take a screenshot from CAD modeling software, Rhino, which is a line drawing or a shaded viewport, and apply the style of reference image to the form of that screenshot to approximate a kind of rendering process. So to get started, just head to runchat.app, sign in, go to the editor and click Start from Scratch. So the first thing that we're going to need for this workflow is a screenshot from Rhino. So I've got the trusty Revit example model here, which is currently in a monochrome viewport, and I'm just going to screenshot part of that view. That'll get copied to our clipboard, and we can paste that straight into Runchat so that we have that image. The second thing that we'll need is some kind of reference style image. Now you can use images that you find on the internet or images of work that you've produced before, or you can create images yourself. I'm just going to use Flux Ultra and create a reference image here. So let's try writing let's just give that a whirl. We'll make it a square image, we'll create 4 variations on that and hit run. So to create our reference image, you can use a generative model or you can use actual photographs on the internet. While that's running, we're going to create our next node. Oh, it's already finished. They look fine. We'll grab one of these and that can be our reference image. So we use a model called SDXL IPAdapter for applying the style of one image to the composition of another image. So this model, SDXL IPAdapter, it's using IPAdapters, which stands for image prompt adapters, to, you can think about it as take this image and kind of convert it into a text prompt, which will produce a similar looking image. And it's also going to use something called control nets to match the depth and or edges of this reference image here, so that we'll end up with something which either has the same silhouette or the same form or both. So I'm going to plug in my composition image, which is my Rhino screenshot, and I'm going to plug in my style image. And for our prompt, let's use the same prompt that we used to generate our style image. You don't have to use the same prompt here. Obviously, if you've got an image off the internet, you're not going to have the prompt for it. Just make sure you describe what you want this to look like an exterior shot of a building made of timber and steel and glass or whatever it might be. Okay, next we need to set up the settings for this node. And this is where we can control how much we want the generated image to match the edges of this model or the depth of this model. I'm going to turn edges up a little bit. We'll leave depth on 0.6, we'll leave style on 0.7. Denoising sets how much we exactly match our composition image. So if we set this to 0, the model won't change this image at all. If we set it to 0.5, it will be very, very similar to this image. We'll probably get something that's black and white. If we set it to 1, it basically ignores this image altogether and just uses the control net, so the edges and the depth of this image. We can leave it at 0.9 for now. Composition tries to match the composition of this image, like where the forms are located in the image. We can leave that as the default as well. And what we want to do is we want to, I'm not sure what resolution this screenshot is, but potentially it's quite high res because I just grabbed it from my computer. And so I'm going to resize our input images so that we know that they match a resolution that's supported by SDXL. I want to have my edge processor turned on and my depth processor turned on. And that's because I'm not providing a Z depth image here, I'm providing a screenshot. and I'm also not providing perfect line work. So these edge processors go and take this screenshot and process them into either edge drawings or depth maps before they're passed to the model. Okay, so this model takes about 30 seconds to run. That's partly because it's got to download the control net and IP adapter weights in the background before it can generate the image. And once it's finished, what we should get is a image which has a lot of the color and forms in the foreground, so grasses and things like that, of our reference image, while matching the silhouette and form of our composition image. One of the downsides of the IPAdapter, SDXL IPAdapter model is, while it does a really great job at matching form and style, it also tends to introduce small artifacts in the generated image. So if we zoom in here, you'll see stuff like the end of this one's not perfectly straight, there's not perfectly horizontal lines in here, the image itself is maybe slightly blurry, but it's matched the composition and style pretty well. So the last step typically in a kind of rendering workflow like this is to take the output of our SDXL model and plug it into a Flux model, either Flux Crea or Flux Dev. We'll try Crea with the same prompt again. So just going to grab that same image prompt. And this is the Flux Dev and Flux Crea models. They're both image-to-image models, which means that they use an input image as the start of the diffusion process instead of random noise. And we can adjust the strength of that input image, or the strength of the diffusion process. So if we set this to 0, the diffusion doesn't do anything. We end up with exactly the same image as our reference. If we set it to 1, we basically ignore the reference image and generate a new image entirely. And if we set it somewhere in between, like maybe just 0.25, and run that, what it does is it kind of lightly regenerates this image, which can help with things like straightening up verticals and horizontal lines and things like that. So that's done an okay job at cleaning this up a little bit. Maybe we try the other one as well, and we'll maybe let it run a little bit more. So you can play around with the strength, like how much it regenerates the image, and the number of inference steps to control this kind of polishing step. Alright, that looks a bit better. We're going to call that done. The last step in a rendering process typically is that you will want to take this image, which is still fairly low resolution. That's partly because we resized it initially back here. And you'll want to upscale it. So there's 2 upscale models which are included in Runchat. There's a very, very fast, very, very cheap one, which you always should try first, the crisp upscale. So we'll run that, which does make a high resolution image, but also tends to produce artifacts. And then there is a slower creative upscale, which does a better job of preserving features in the image without introducing artifacts. You can see that it hasn't done too badly, this one actually, but we've still got some kind of wavy lines in here, but that is more expensive, the creative upscale. So you want to try both. Typically, depending on the image that you're working with, one might be better or worse than the other. So this is a very high resolution image. Compared to our initial input. Alright, the other technique that we want to use is just edges. So in Rhino at least, that's pen mode, and maybe just for fun we'll do a portrait render. So we can change this to portrait. We'll pick a different view of this building, the Revit example model. Alright, maybe we'll do, let's do that one. and we'll throw that into Runchat. And just for fun, we'll pick a different reference image. Maybe we'll try one that's got a bit more bush in it. Let's use that one. And then we use our SDXL IPAdapter node again, composition image and reference style image, and we'll use the same, once again, prompt that we used to generate our image. We'll configure this one slightly differently because now we only have edges, we don't have depth information. So the shading helps quite a lot with the model guessing the three-dimensional form of things. When you've just got edges, we tend not to have that. So I'm going to turn up our edge to 0.5, so it'll roughly follow edges, and I'll turn depth down to nothing. And then we're not going to use an edge preprocessor because this is already edges, and we're not going to use a depth preprocessor. And let's see how it goes without resizing the image as well, just so we can compare it to this kind of lower resolution output that we got there. And while we're at it, we'll get our Flux post-process node set up and ready to go. We need our prompt for that one too. And we'll configure that to run for 0.3. Maybe we'll try running it for a few more steps this time. Okay, that's done well. So you can see that the quality of the image is great, but we've hallucinated some space or some building in here which doesn't exist in our reference image, which we most definitely don't want. So we can try turning up the weight of our edge control net. I'm going to turn that up to 6, and I'm going to turn down or off the composition weight. So that's where we're trying to kind of match the composition of this image. Let's just turn that off. The other thing actually, which is more likely to be producing that kind of defect, I might leave the composition up and the edge up as well actually. When you have this situation happening where there's parts of the image which are kind of being repeated, that can be because of your input resolution just being too high for SDXL. So before I change any other settings, I'm going to try just resizing our input image and hitting go on that one. So what resize does is it just makes sure that this input image here is sized to a resolution that SDXL is trained on, and it helps to remove those or avoid those artifacts where parts of the image look like they're copied within the image. Sometimes it's fine. In this case, it seems like it's a little bit problematic. Okay, that's fixed that problem well and truly. And now we can go and apply that post-processing step where we just run it again with Flux to try and polish that up a little bit. So that output looks pretty good. There's no obvious immediate artifacts with that one. Let's go ahead and upscale it and see how it goes. This time we will use the creative upscale. This does use a lot of tokens, so you want to use this when, or use a lot of credits. You want to use this when you're confident that the output of the image is something that you're actually going to use. But we'll run one now just so that you can get a sense of the quality that it produces. Okay, so that's finished, and let's just open that in a new tab. So you can see that the creative upscale, there's some pros and cons with it. You get a very high resolution image without too many artifacts, but it can sometimes introduce a little bit of blur. So these trees here, we've got a tiny bit of blur. There's like a little bit of a glow around a lot of the parts of the image. It kind of looks AI-ified. But we do have an extremely high resolution image, and we could go and pull parts of this image out, pass them back into Flux again, just to clean up some of those, that glow, if we really wanted to. All right, have fun with that.